Stoate. I'm Head of Research at the Allerton Project Research and Demonstration Farm in central England, and I'm study site lead for the study site in the SoilCare project. There's a major weed within our arable systems at the moment called blackgrass, which is very competitive and difficult to control, but having 3 or 4 years of a grass ley does help to control that weed. Grass leys also help to improve soil structure and organic matter within arable rotation, so there's interest from the farmers in from that perspective. But there's also potential for improving water infiltration and achieving catchment management objectives by increasing the area of grass leys in arable rotations. What we have here is 5 test cultivars, different modern agricultural grasses. 4 of them are festiloliums, which are hybrids between ryegrasses and fescues, and the other one is a coxfoot. So we have 3 replicates of those treatment cultivars and 3 controls in the experimental plots that we have here, and we're gathering data that they're managed in just the same way as conventional grass ley would be. They're cut for silage and grazed by sheep. And we're collecting a range of data from these plots, but in particular we're interested in soil organic matter and in those infiltration rates. We've been interested in the possible negative impacts of grazing and harvesting the grass. Might have negative impacts on the rooting properties of the grasses and subsequently on infiltration rates. So what we did at the end of year 2 is to fence off the bottom of the plots to exclude grazing, and also so there's no cutting for silage. So we were able to gather data from conventionally managed, harvested parts of the plot and unharvested, ungrazed parts of the plot, and compare both infiltration and the rooting capacity of the plants as well. We've found some quite surprising results actually, where the grass is grazed and cut for silage. We're seeing actually higher root volume at depth in the grazed part of the plot than in the ungrazed and unharvested part of the plot. So the deep rooting grasses are not delivering in terms of root volume at depth where the grass is grazed. Where the grass is not grazed or cut for silage, then they're really having some very substantial benefits. So very much higher root volume for the variety Fojtan and the coxfoot donata than the control plots. We got some really interesting results for water infiltration rates across the different treatments. So the first year after establishment, much higher water infiltration rates from 3 of the test cultivars, actually the deep rooting grasses. Much higher infiltration rates than the control and than 2 of the other test cultivars. So that was really encouraging. If we can use these grasses to improve infiltration rates, that could have some benefits up the landscape scale in terms of flood risk attenuation, flood peak attenuation, or reducing runoff and impacts on water quality. So in subsequent years we didn't see those differences in infiltration rates between the plots. And we think this is probably because of compaction caused by the sheep, in particular in the autumn when the soil is wet. The farmers have been a bit concerned that the sort of societal benefits associated with improved infiltration only arise where harvesting is limited and grazing is not present or is reduced. So that's an area where there would need to be funding through an agri-environment scheme, for example, but that's an opportunity for the new schemes that are coming along, and the new schemes are in fact starting to do that, providing incentives for reducing grazing densities and not stocking at times of year when the soil is vulnerable through wet conditions. So our results would certainly support that move for sort of supplementary funding to farmers to reduce the intensity of grazing and improve these infiltration rates to deliver societal objectives.